So hi again, physics. This is going to be part 2 of homework number 4, problem number 4. So we've already done step 1, step 2, which had an ugly vector, so we had to do a step 0, and then we did step 2 again, which is another free body diagram, but this time with only pretty vectors. So where do we go from here? After step 2, let's make a little bit of room here. After step 2, you go on and you do step 3, and this is a two-dimensional problem, and you want to do the y side first. So it's going to be Newton's second law with just the y forces. So F equals ma, but really it's sigma F equals ma. Force and acceleration are vectors, they were hats, and we need extra subscripts. So just y. So let's look at the a sub y. Let's go back to our sketch and see what's going on. What is the acceleration of this couch in the y direction? It has none. The couch is not accelerating in the y direction at all. That would be the couch flying up in the air, which it's not doing, or the couch diving into the ground. It's not doing that either. So a sub y ends up being 0 meters per second squared. That's going to be really common in these problems. Typically the thing is not going to accelerate in the y direction. It may or may not accelerate in the x direction, but it's not going to accelerate in the y direction. So if I go back to here, I know right away that a sub y is going to be 0, so the right side of this is just going to be 0. Now how about the left side? Sigma f sub y. What is that going to end up being? What you do is you go back to your free body diagram, you grab all of the y forces, you put hats on them, and you plus them together. So we're going to ignore the x forces for now, just the y forces, give them hats, plus them together. So the forces we have are f sub n, f sub dy, and f sub g. Those are our y forces. That means the left side of this is going to become f sub n with a hat, plus f sub dy with a hat, plus f sub g with a hat. Now on to step 4 on the y side. So step 4 is math. The first part of math in a force problem is take the hats off and put in the signs. So what signs are we going to get? Well, f sub n and f sub dy are both going up, so those are going to get pluses. F sub g is going down, so that's going to end up getting a minus. So I'm just rewriting this, but again, I'm taking off the hats and putting in the signs. I'm going to end up with f sub n plus f sub dy minus f sub g. All of this equal to 0. Next, let's see, what are we actually looking for? We're looking for the normal force. So I want to try to get f sub n by itself, so I'm going to subtract f sub dy from both sides, and I'm going to add f sub g to both sides. And that's going to give me f sub n is equal to minus f sub dy plus f sub g. So f sub dy is a number I already know. I figured that out in step 0. F sub g, I've got to sub in my formula for what that actually is. So minus f sub dy plus, instead of f sub g, this time I'm going to write mg. Because that's your formula for the force due to gravity, which is also called the weight. So now we're going to plug in our numbers for this. So minus f sub dy is going to end up giving us minus 128.6 newtons. And again, I got that back here. This comes out of my step 0. That was my value for f sub dy. Plus mass times g. Okay, so the mass of this couch was 158 kilograms, and g, we're using positive 9.8 meters per second squared. Again, we use the positive number because we already accounted for the fact that gravity is going down, and we did that right here. when we went from step 3 to step 4, when we took the hat off of f sub g, we gave it a minus sign to account for the fact that it's going down. So we want to do that exactly once and not do it twice. So I've got that. If I do all of that in my calculator, the number I'm going to get is 1419.8 newtons. So I'm keeping too many sig figs, but I'm okay with that. Because this is a number we're going to use, I don't want to round it off too much. So it's a little bit sloppy. I have college professors who would yell at me for that, but I'm going to let it go. So we have our normal force. Quick step, we solved for what we wanted, which was normal force. We gave it the right units, which was newtons. Is this a reasonable number? Trust me, that is a reasonable number. So we've got all that. Now we have to go on and do step 3. Let me go with black this time. We want to go on and do step 3 on the x side. So Newton's second law, F equals ma, but it needs to be sigma F. F and A need to wear hats, and we need extra subscripts because we're only dealing with x forces and the acceleration in the x direction. So now in this problem, a sub x. In these problems, that's not always going to be 0, but if you go all the way back to our sketch, and remember that we had this red herring here. We knew what the velocity was, but we knew that that velocity was constant. So we already knew from the beginning of this that our acceleration in the x direction is 0. So again, this is not going to be true in all of these problems, but it is true in this one. A sub x is 0, which means at least in this problem, the whole right side is going to be 0. So now we need to deal with sigma f sub x. So what's that going to be? Go back to your free body diagram, ignore your y forces, grab all of your x forces, so f sub k, f sub dx, and f sub c, put hats on all of those forces, and plus them together. So that's going to give us f sub k with a hat, plus f sub dx with a hat, plus f sub c with a hat. Hopefully the purpose of the hats is starting to make a little bit of sense. If we look back at our free body diagram, we've got a lot of forces. It's a lot to keep track of, so you don't want to make your lists of your forces and figure out their signs all at once because it's too easy to make a mistake. So the purpose of the hats is it makes it really easy to make just lists of your forces at one point and then to figure out their signs at another point. So that's the purpose of the hats. So if we go on to step 4 on the y side, which again, this is math. First part of math, take off the hats, put in the signs. F sub k, well that was going left, so that one's going to get a minus. So minus f sub k. F sub dx and f sub c, both of those are going to the right. So f sub dx plus f sub c. All of this is equal to 0. So which of these things am I trying to solve for? If you go back to step we're looking for f sub c. So I've got to do some algebra to get f sub c by itself. That's going to end up giving me f sub c is equal to f sub k minus f sub dx. So f sub dx is a number I already know. I figured that out when I was doing step 0. What about f sub k? So again, if you check the footer at the bottom of your page, f sub k, there's a formula we're going to sub in for that. That's going to be equal to mu sub k times f sub n, and this gets minus f sub dx. So I know what these numbers are actually. Mu sub k was a number I was given, 0.200, and again, it's a little bit weird, but there's no units on that. F sub n, that's what we figured out back here. What's the normal force between the couch and the ground? 1419.8 newtons minus f sub dx. And again, f sub dx, I figured that out right here. So that's a number I've known already. That's 153.2 newtons. 153.2 newtons. If you do all that in your calculator, you're going to end up with F sub C is equal to 130.8 newtons. Put a box around it, and then do a quick step. Well, I was looking for the force of Charlie. I expected to have units of newtons. And what did I find? I found the force of Charlie. I gave it the units of newtons. And then is this number 130.8? Is that a reasonable number of newtons for someone to apply? Turns out it is. So that works. I'm happy with that. So hopefully this helps.